Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know about quadratic equations. So let's start with expanding. You probably already know how to do this. We can use FOIL or we can use the principle whereby you multiply everything in the first bracket by everything in the second bracket. So if I do that second option, I need to take x and multiply it by the second bracket and then take -4 and multiply it by the second bracket. So we go x times 2x, x times 1, -4 times 2x, -4 times +1. And then we just make sure we collect the like terms. We get 2x squared minus 7x minus 4. All right, how do we expand those higher powers? So remember, the way we do this is we take our first term, which is 2x, and we start off with the power of 4, the highest power. And then with each subsequent term, we decrease the power by 1. So it'll be 2x cubed. The next term will have a 2x squared, and we do so all the way down to 0. So then we take our second term, which isn't 3, it's -3. We go the opposite way. We start with the highest power over here, and we're going to decrease the power each time. So we have 1, 2, 3, 4, 5 terms. Each term needs a coefficient. You get the coefficients from Pascal's triangle. So note, Pascal's triangle starts with row 0. So it's row 1, row 2, row 3, row 4. If it's to the power of 4, the coefficients are from row 4 of Pascal's triangle. So here, row 4, the coefficients are 1, 4, 6, 4, 1, and put a plus between each of the terms. Now we just need to simplify each term. So this first term, 2 to the power of 4 is 16, so that's just 16x to the power of 4. Next term, 4 times 2 cubed, 4 times 8 times -3 gives us -96 x to the power of 3, and so on. So note that if the second term is negative, every second term of your expansion should be negative. All right, let's look at a harder question involving expansions. So here we're told the value of x plus y and xy. We need to calculate x minus y. So hopefully you see that these are related through the expansion of x plus y squared. So if I expand this the quick way, I square the first, square the second, which is always positive, and in the middle is 2 times the product of the terms. So this must equal 16 because we have 4 squared. So we know that the value of 2xy must be 2. So in that case, I get x squared plus y squared is equal to 14 because this is 2 times 1 or 2. Now, what would happen instead if I did x minus y squared? Well, you'd get almost the same as this here, except the middle term would be negative. You'd get x squared minus 2xy plus y squared. Now, we know that x squared plus y squared is 14. We just figured that out. So this will be 14 minus 2xy. But xy was 1. So x minus y squared is 14 minus 2 times 1, which is 12. So x minus y is just the square root of 12, or x minus y is the negative square root of 12. So either of those values is possible. All right, let's now look at solving quadratic equations. So we learned how to solve quadratic equations through factorization. You factorize differently whether it has 2 terms, a binomial, or 3 terms, a trinomial. So for 2 terms, you are either going to use highest common factor or difference of 2 squares. Now, whenever you're factorizing, you should always first check for a highest common factor. So when solving this equation here, 4x squared and 6x have a common factor of 2x. You write that out the front. So what do I times by 2x to get 4x squared? Well, that's 2x. What do you times by 2x to get negative 6x is negative 3. See, the reason factorizing is a popular choice for solving quadratic equations, you can use the null factor law. If you have something times something equals 0, either the first something equals 0, so if 2x equals 0, that means, of course, x is 0. Either the first something equals 0 or the second something equals 0. If 2x minus 3 equals 0, that's just a linear equation. You get x equals 3 over 2. So if I try and solve this one, it still has two terms, but there are no common factors between first and second term. When that happens, try the difference of two squares. Difference means minus. If you have a perfect square minus a perfect square, you can factorize it by setting up two brackets. You square root the first, so square root of 9x squared. You square root the second, so square root of 100 is 10. One bracket gets a plus, one gets a minus. Now that it's factorized, we can use the null factor law. It tells us either the first something or the second something equals 0. So the solutions you get are positive or negative 10 over 3, and we're done. Now let's look at where we have three terms. So if it's monic like this one, we find two numbers that multiply to the constant term and add to the middle term. So we're going to set up two brackets, and those numbers about which I just spoke go in the brackets with the x. So two numbers that multiply to negative 90 and add to negative 9. If you're not sure, you can just go through factors of 90. For example, 10 and 9 won't work because they won't add to negative 9. But negative 15 and positive 6 will work because these two numbers multiply to negative 90, add to negative 9. When you factorized, we can use the null factor law. Either the first something equals 0, which would mean x is 15, or the second something equals 0, which would mean x is minus 6. Now, when you have a non-monic trinomial, it's a bit more complicated. You need to use the AC method. This is A, this is C. So when I multiply together A and C, I get negative 30. I need to find two numbers that multiply to negative 30 and add to negative 7. Those numbers happen to be negative 10 and 3. If you're not sure, just go through factors of this number. So for the AC method, with those two numbers, I split up the middle term. It doesn't matter which way around. I'm going to use 3 and minus 10 because they were the two numbers that multiplied to negative 30 and added to negative 7. But it wouldn't matter if I switched these two around. So now what you do is factorize the first two using highest common factor. So the highest common factor there is 3x. And then I factorize the second two using the highest common factor. It's negative 5. So when you're doing this, if you've chosen the numbers correctly, you will get these two brackets being the same. So factorizing again, between this and this, the highest common factor is 2x plus 1. The other stuff just goes in the other bracket. So now that I've factorized, I can use null factor law. It says either the first something is equal to 0, so that would mean x is minus a half, or the second bracket, the second something is equal to 0, and that would mean x is 5 over 3, and we're done. All right, let's now look at some harder examples. So neither of these equations are actually quadratics, but we can use what we know about quadratics to solve them. See here, the three terms have a common factor. They didn't in the trinomial examples I did on the previous slide, but here they do. The common factor is x, so I first take out that factor. And then I'm just left with a monic quadratic trinomial. I'm going to solve it the same way I did on the previous slide. Two numbers that multiply to that, add to that. Turns out the two numbers that multiply to 1 and add to negative 2 are both negative 1. So here we have either the first thing is equal to 0 or the second thing is equal to 0. And they're my two solutions. So let's look at this one here. These three don't have a common factor, and it doesn't at all look like a quadratic. But you have to be aware sometimes you can make a simple substitution to make them look like a quadratic. Because this is this squared, I can simply substitute y equals x to the power of 4. Using our index laws, this will be y squared. X to the power of 4 squared is x to the power of 8. So I'm left with y squared minus 14y minus 32 is equal to 0. So this is just a normal monic quadratic trinomial. Two numbers that multiply to that and add to that, I end up getting negative 16 and positive 2. Okay. So solving that using the null factor law, I get y equals 16 or negative 2. But I'm not done because I need to find what x is, not what y is. But y is x to the power of 4. So I have either x to the power of 4 is 16 or x to the power of 4 is negative 2. Now, this second one doesn't have any solutions. If you have an even power, the answer cannot be negative. So there are no solutions here. But this one actually gives me two solutions. If you have an even power and positive answer, there are two solutions. The fourth root of 16, which you can use your calculator, is 2, but there's also negative 2. They are my two solutions, and I'm done. Let's now look at the quadratic formula. So if ax squared plus bx plus c equals 0, this is just a general quadratic equation. This is the quadratic formula that allows you to solve it. Now, when you're solving, you should first calculate this, the discriminant, b squared minus 4ac. B is the coefficient of x, a the coefficient of x squared, and c the constant term. If you calculate the discriminant first, it'll tell you how many solutions that you get. So let's solve this equation here. I can't factorize this like on previous slides because there's no numbers we can think of that multiply to 3 and add to 5. So I'm going to use the quadratic formula. First step, I'm going to calculate the discriminant. It's b squared minus 4 times a times c. A is 1, b is 5, c is 3. So you can use your calculator for that if you want. You get 13. The discriminant is positive, so there are two solutions. So what are the two solutions? You've got x equals minus b plus or minus the square root of the discriminant over 2 times a. So the two solutions are minus 5 plus root 13 over 2, and the other one's minus 5 minus root 13 over 2. So if you get such a question, make sure you're clear from the question whether to give it an exact form like this or you have to round your answers. If you had to round your answers, just put these in your calculator. All right, let's look at a harder question involving the quadratic formula. So we're going to calculate possible values for k if this equation has at least one solution. So if it has at least one solution, that means the discriminant is greater than or equal to 0. Greater than 0 means two solutions, equals 0 means one solution. So the discriminant of a quadratic is b, so this is b here, b squared minus 4 times a times c. So we need that to be greater than or equal to 0. So just cleaning that up a bit, 4 times 400 is 1600. Okay, so we can factorize this using the difference of two squares. So when you have a square minus a square, you get two brackets, square root the first, square root the second, one gets a plus, one gets a minus. So we're saying that this times this has to be positive. So there are two options here. Either both of these are positive, which would mean that k is greater than or equal to 40. The other option is this and this are both negative, and that would mean k is less than or equal to minus 40. So they are the possible values. Anything for which k is greater than or equal to 40 or less than or equal to minus 40. If k is say negative 20, it's between these two values, then there will not be a solution. All right, one more thing to go through, and that's a worded question. So we're going to calculate the dimensions of a rectangle, perimeter 88, area 384. So it might be helpful sometimes to draw a diagram. We've got this rectangle here. So I'm going to call its width here x. So I need to find the length in terms of x. I can't use a y here because we don't know how to solve quadratics where there are two variables. Now, if the perimeter is 88 centimeters, that means it's 88 all the way around. So that means the length and the width add to half the perimeter, they add to 44. This plus this is 44. So if the width is x, the length is 44 minus x. So the area is just width and length multiplied together. I'm solving this equation here. Now, whenever you're solving a quadratic equation, whether you're using factorization or quadratic formula, you must first make one side equal 0. So I'm going to expand the brackets here. I have one side equals 384. So what I'm going to do is move both of these to the other side. I need one side to equal 0 before I factorize or use the quadratic formula. So I get x squared minus 44x plus 384 is 0. Now, if the numbers are big here, like 384, it might have lots of factors. So rather than wasting your time trying to go through the factors of 384, let's just use the quadratic formula. So to use the quadratic formula, we're first going to calculate the discriminant. So discriminant is b squared, so negative 44 squared, minus 4 times a times c. So putting that in our calculator, we get the discriminant is 400, so there are two solutions. Those two solutions, x equals minus b, so negative minus 44 is positive 44, plus or minus square root of discriminant, all divided by 2 times a. And the answer we get, 32 and 12. So this rectangle must have a width of 12 and a length of 32. All right, thank you so much for tuning into this video. Best of luck studying, but you'll ace the test, you're a star. This has been the luckiest maths teacher in the world. Have a great day.